All right, so we got movement in our game, although it's not ideal for we can go through the walls on the side of our board, just like these other balls are doing. So we have movement, but we need physics-based movement. We need to be able to interact with the world around us. So unfortunately, the way we've done movement isn't going to cut it. We need to improve our movement techniques, our movement coding. And it's going to get a little complicated, but this is basically the boilerplate for all movements in your 3D Unity adventures. So once we have the code, we'll not need to mess with it anymore. And we can basically just copy and paste it whenever we want. So player one is the main player for now. I need to basically interact with the world around me, such as those walls. They need to stop me. So whenever you're doing movements and you need some physics, there's a couple of things you can do, but I highly recommend adding a component and adding the character controller components, which I've already done. Apparently I've already done. I will just remove it so I can add it again. The character controller components. You could add a rigid body component, but you're going to run into some issues with how that handles physics in a much more complex way. So let's just stick with the character controller. Now, depending on the size of your game objects in your scene, immediately I am getting an error down below. If you click on the console tab, you can see that this may be the first error you've encountered. And the error, just as it says, is step offset must be less or equal to scaled height or plus scaled radius times 2. So the step offset is just a little too high for my player game object is pretty small. So I'm just going to bring this down to 0.1. Maybe 0.01. Let's run it, see if the error goes away. Cool. 0.1 probably works just fine. So I need to move this ball through the character movement, the character controller. It is no longer just good enough to translate my game object. I have to move it through the controller, this character controller. Otherwise, the physics won't move with it and it won't interact with the world around it. So let's go back into our player controller script and don't need that. This is probably what you should have. And we don't need to delete anything too much, except we do need to modify this code. Instead of interacting with the transform components on our player, we're now going to interact with the character controller components. And what I'm about to show you really encompasses what Unity is all about in terms of the cross communication between code and components and game objects. If you were a thinking person, you would say, well, I could talk to the transform component just by using the word transform right there. So one would think I could talk to the character controller component just by using the word character controller. If only it was that simple. Typically, if you want to talk to any of these components that you've added onto your game object, such as the character controller, what you have to do is you have to go to the top of the script where we had the speed, or just under the main class there. And I need to basically create a field to interact with a character controller component. So I'm going to type in character controller, and I can just call my character controller controller, because why not? So basically, now that I've told my code, hey, we're going to be talking to a character controller component, and anytime you want to talk to this component, you're going to use the name of the component, which we're calling controller. So instead of moving through the transform, I would like to move through the controller. So I'm going to use the same name I used up here. Now the controller, the character controller component, doesn't have a function or method called translate. It has instead called move, because I want to move the controller and I want my game object to move with it. I don't actually have to change any of these arguments for this particular function, but we're talking about physics, so I want to do more. I want to add gravity, because if we just pull the plug right here and we call it a day, yes, I will get interaction with the world around me, but I won't get gravity. So I will kind of start to float up into the sky. So now we could just leave it with this new updated method, but we are adding physics. So this will allow my game object to interact with the world around it, but it's not going to behave the way I want it to, because with this character controller component comes interaction with the world around it, and I need to apply physics to this game object now, because if it bumps into a wall, it may get bumped into the air, and if it gets bumped into the air, is it going to stay in the air? No, it should probably come down. So we're going to complicate this script further. You've already got speed up here. I would like not speed, but I would also like gravity. And gravity falls at 9.81 meters per second. And I would really like to jazz up this script. I'm going to keep track of the direction my game object is going in the form of velocity. So this vector 3, which we talked about, that's going to point to, well, it's going to show you literally the arrow of where your character is moving. And we are going to use these two things in tandem to make sure that gravity works perfectly fine. All right. So now we can basically include some physics. So if the character component, the character controller component I just added, is grounded, it's a lovely built-in method. If this character controller capsule is on the ground, if it's touching the ground, and velocity in the y direction, remember where the y direction is, right? It's this green axis. It's the up and down. Oh, I can't rotate. It's the up and down direction. So if that y component happens to be less than 0, we are going to say that the new velocity in the y direction is going to be equal to negative 2f. Okay, what did we do here? We did a little trick. We did a little sneaky thing here. If we are on the ground and our velocity in the y direction, if our speed in the y direction is less than 0, I'm basically going to hard code that y velocity to be -2. And what this is a correction factor, such that if your character was to ever move over a little bump on the ground, they may get stuck in the air. So what I'm doing is I'm basically applying a force to my character downwards into the ground at all times. I'm basically applying gravity to my character even when he's touching the ground. I'm trying to push him, but I'm not going to push him through the ground, because that character controller is interacting with the sphere collider. There's a lot going on here. I do apologize. I'm trying to explain it once so that I can never explain it again, and we can just copy and paste the code from here on out. So this velocity in the y direction is not actually applied to my character yet. It's just a random 3D vector. So I'm going to take that y velocity and I'm going to add it to my gravity, if I can spell gravity right. And I'm going to multiply it by our lovely time delta time correction factor. And the reason I'm doing this is because much like we moved the controller and the game object up here, I need to account for gravity. So I'm also going to move my character controller in the direction of the velocity, which is really just a y direction. We're not worried about x and z. We've only talked about y when it came to velocity. And I'm going to multiply it by time delta time. This should be the final code for movement for our character. This will be on canvas for you to copy and paste in future. This is some good complicated code. Even the coders in the class may have trouble trying to grasp this. I know I do the first time I looked at it. Anyways, so after all that rambling, you may think, all right, good, we've got physics, we've got gravity. Let's go back to Unity, let's compile the scripts, and let's see what happens. And you may be quite disappointed to see that, well, we're actually not going to see anything because Unity has stopped us, because there's one crucial mistake that we make when we try to talk to game components on our game objects. Let's go back 5 minutes. Remember what we did here? I said I wanted to talk to the character controller component on my game object, right? This thing right here. So I named it, and I've been interacting it through the controller name. This is the basis of Unity here. I have a character controller right here, and my player one, my player controller script, look at this field right here, controller. It doesn't know which character controller to talk to. I know there's a character controller component attached to the same game object as the script, but this script doesn't know that it's talking to this character controller. Maybe there's a character controller on player 2 it needs to talk to. Maybe there's a character controller on player 3. So what I have to do is in the controller for the script, I have to click and drag the game object that has the components I'm interested in talking to. In this case, it's myself. There is a character controller on player 1. So I'm going to click and drag player 1 game object into my controller field for the script. So now there's no ambiguity in which controller this script is communicating with. That is really the basis of Unity and that interaction between scripts and game objects. So now my game actually runs, there's no errors. And if I run into these walls, I'm getting stopped. And there's one last little tweak we need to make. I'm kind of floating in the air right now. So let's go to this character controller game components. And let's change the skin width to be less. So let's try 0.01. That's going to make my capsule less thick, and it's basically not going to push me off the ground as if I had really thick skin. And now it looks like I'm gliding on the ground, and look at me just try to take out that frickin' ball and hop over it, and gravity took me and it slammed me right back on the ground. So now I'm interacting with the world around me as I move through this game. If you are overwhelmed by this code, you can literally copy and paste this off of Canvas whenever you need it, and it will never change. This is your go-to movement for your 3D game development for the rest of the course.